Hello everyone, my name is Dr. K.C.H. Apparao, working as an associate professor in mechanical engineering department. Okay, in this class, we'll see the question bank discussions, mainly the critical thinker questions, which are focused on the boiling process. So here some questions which are given in the question bank explain the different phases of boiling heat transfer phenomena. We'll see what is nucleate boiling, explain properly. Write the correlations for boiling heat transfer in case of nucleate boiling, and classify the different types of the boiling also. So next we will see the what is boiling, what is the phenomena of boiling also we'll see. Okay. So first of all we will see what is the introduction of boiling. We know that two terms, boiling and condensation. First we'll see what is boiling. Okay. So we know that convection process is the process in which heat is transferred from solid to fluid or fluid to solid, okay, without any phase change. You know this one. We already discussed this in previous classes also. But in case of boiling and condensation, we will see the heat transfer along with the phase change. Okay. So here we will observe the changing of the phase. So in the boiling, liquid is converted into vapor. Condensation, vapor is converted into liquid along with heat transfer. Okay. So the transferring heat to converted as just latent heat. So this is completely associated with the phase change. So latent heat affects associated with the phase change. So this is very significant parameter. Okay. So boiling is the process associated with the change in phase of fluid along with the heat transfer. Next, vaporization of the liquid to vapor state. Okay. Result by heat transfer from the solid surface. Condensation of vapor to liquid state results in heat transfer to the solid surface. Okay. So in addition to the latent heat, two other parameters are very important in characterizing the this process. Namely, surface tension is very important for the formation of bubbles and something, and the density, and this one also very important between the two phases. Okay. So now we'll see what is boiling. Boiling is the process convect to heat transfer process along with the phase change. So boiling is the convect to heat transfer process that involves a phase change. So liquid to vapor. Liquid to vapor. Boiling is also defined as evaporation at solid liquid surface. Evaporation of the liquid. So we can define like this one also. It is the evaporation at a solid liquid surface. It is possible only, that is very important. The temperature of the surface temperature Ts must be exceeds the saturation temperature of the liquid, T saturation. Then boiling will occur. Okay. So heat is transferred from solid surface to liquid to the laws according to laws. We know this one according to convection process. Q is equal to Newton's cooling law. HA into delta T is the temperature difference. Okay. So here A is the surface area, H is the heat transfer coefficient. We know this one. A is the area of the surface, delta T. So delta T is the temperature difference. So temperature difference means this is nothing but TS, solid surface temperature, minus T saturation. So liquid saturation temperature. So this is nothing but it is represented with delta T, excess temperature. If there is a excess temperature, then boiling will be placed or will be comes into function. Okay. So without excess temperature, boiling phase change will not occur. So this is the boiling. We'll see types of boilings. Pool boiling. Next to forced convection boiling. We know that in convection there are two types. One is the natural convection. Second one is the forced convection. So pool boiling also very related to natural convection. Natural convection. So forced convection, so related to forced convection. Okay. So we'll say first of all pool boiling. So in this case, the liquid above the hot surface, is essentially stagnant, and its motion near the surface is due to pre-convection and mixing induced by bubble growth and detachment. Okay. So suppose this is the container. If you give the heat to the container, so this is the liquid. Okay. So it is in stagnant position, not moving position, but the particles which are very near to surface, those particles will be heated. Okay. So and forms the bubbles. These bubbles comes to the upward direction, then just goes into the vapor position. It means liquid is converted into vapor by the help of buoyancy. So the bubbles which moves in upward direction by the effect of buoyancy. So less density particles. So we know that in natural convection, less density particles move into upward direction, heavy density particles move into downward direction. But if surface temperature is greater than the saturation temperature, the liquid which are very near to surface, those liquid particles converted into vapor particles, just like bubbles. These bubbles dispatches and comes to upward direction, and it moves into atmosphere. So here phase change occurs due to pool boiling. Okay. So it means this movement of bubbles occurs by the effect of the buoyancy. So this process is nothing but pool boiling. Okay. So next one is the forced convection boiling. So very similar to forced convection process. We know that what is forced convection. So convection is completely associated with the bulk movement of the particles. Without movement of the particles, so convection doesn't place. We know that one. Okay, movement of the particles here or movement of the bubbles here occurs by the effect of some external agents. Okay. Here we can see forced convection. This refers to situation where the fluid motion is induced by external means. Okay. So movement of the particles or fluid motion occurs due to some external agents. Okay. So these bubbles are induced mixing. The liquid is pumped and forced to flow. So this is the external forced convection process. So in this type of boiling type occurs in water tubes and boilers involving the forced convection. So this type of boiling occurs mainly in tube boilers. Okay. So the water is forced when the water is moving in the tube boilers automatically because of the excess temperature delta E. the water particles are converted into bubbles and vapor particles, vapor bubbles. Those bubbles are moved to top surface. So this is the forced convection process. Now we'll see subcooled and local boiling or saturated boiling. So two more classifications. So in this case, liquid temperature is below the saturation temperature. Okay. So bubbles are formed in the vicinity of heat surfaces. Here, liquid surface, liquid temperature is below the saturation temperature. So bubbles are formed in the vicinity of heat surface. These bubbles, after traveling a short path, but get condensed. So the 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 particles which are very near to the surface due to heat, yes, this liquid are converted into bubbles. So these bubbles travels to upward direction by the effect of buoyancy, but the here the water temperature is very less, so automatically these bubbles will be condensed. Okay, so the short path get condensed in the liquid which has temperature less than the boiling point, because the temperature here, the liquid temperature is less than the boiling point. Automatically these bubbles, vapor bubbles, will be condensed as water. Okay, so this process is nothing but subcooled or local boiling processes. Now we'll see saturated boiling. What is saturated boiling? Here the liquid temperature exceeds the saturation temperature. Okay, the vapor bubbles formed at the solid surface, here solid surface. Okay, so are then propelled through liquids like this one. These are propelled through liquid to top surface and eventually escape from the free surfaces. Okay, so moves out from the free surface. So this is nothing but saturated boiling. But here also bubbles will be formed, but those bubbles are again condensed due to less temperature of the water. It means water temperature is less than the boiling point. Okay, so these are the two types of the boilings also. So this is very important. The phases of boiling curves, we'll see here mainly three phases. Phase 1, so interface evaporation or free convection, that is the phase 1. So second one is the phase 2, regime 1, regime 2. So this one is phase 2. Okay. Next, this one is the third regime. Okay, third one. So here also it is only one part. So this phase has two parts. One is the bubble condenser in superheated liquid. So bubbles are formed, again condensed in superheated liquid. So here bubbles rise to surfaces, just like here we can see this is the pool boiling or local boiling. These are the saturated boiling. Okay. Next, unstable film. So those bubbles are converted into converting zone. So bubbles formation is converted into film. Okay. So here we'll see unstable film. Next to stable film we'll see. Next to radiation coming into play. So we'll see one by one. So what is the importance of these phases? How the boiling occurs in different phases. Okay. The first one is the interface evaporation phase. So this is nothing but free convection. We know that convection process, free convection. So free convection, if you give the heat to this surface, automatically the liquid which is in this container. Okay. Okay. So here the particles which are very near to surface, those particles will be heated. The less dense particles moves in upward direction, heavy dense particles moves in downward direction. So this one is the free convection process. Okay. So here heat is transferred by superheated liquid rising to the liquid vapor interface. Okay, this is the vaporization takes place here. It means the bubbles, this less density particles moves into upward direction, heavy density particles moves into downward direction, because density is indirectly proportional to temperature. If the temperature increases, automatically particles will be the density of the particles will be decreased. The less dense particles moves into upward direction. So if it has some just like excess temperature very near to 5 degrees Celsius, automatically those liquid particles are converted into vapor particles. Those vapor is evaporated at the interface between the evaporation liquid. Okay, so here this liquid is converted into vapor like. So this is the process. So we'll see clearly in the next PPT, next slide. So just I'm giving the brief description here based upon this curve. Okay, next one is the nucleate boiling. Nucleate boiling means here bubble formation will start here. Here the fluid which is very near to surface, due to the excess temperature delta T, the liquid is converted into some bubbles. This formed bubbles propelled or moves to upward direction due to the density difference. But when they moving, those bubbles are condensed again, because the water which is away from this bottom surface, those water that water has temperature less than the boiling point, automatically. So less temperature, due to less temperature, these bubbles will be condensed again. Okay, so here bubbles formed but again condensed in superheated liquid. Okay, this is the process. And the second one is if the temperature is excess, here excess temperature increases again. So the bubbles rises to surface. The bubble formation increase rapidly. So more bubbles will be formed. These bubbles comes into upward direction and converted into vaporization. Okay, so this is the rapid movement of bubbles. Automatically you will see the mixing of fluid, automatically vaporization and conversion of the liquid into vapor will be occurred rapidly. So in this case, heat transfer rate is gradually increases from starting point to through convection. We will see the heat transfer rate. Heat transfer rate means heat transfer between the solid surface to liquid. So the flux, heat flux, so Q, small q, capital Q by A, will be increased gradually, but it reaches at some point. So this point, that is nothing but a critical heat flux. So this is the critical heat flux, where the heat transfer rate or heat flux is very high at a point. So that is not a critical heat flux. We will find this formula next slide also. Okay, so next one is the film boiling. So next phase, so transition of phase, it means nucleate boiling to film boiling. So here bubbles formation will be stopped. These bubbles mixed with each other and forms a film. Just here we can see. So these bubbles are formed a film, vapor films. So these films act as a pockets on the surfaces. Okay. So due to these pockets, this film act as a resistance to heat transfer between the solid surface to liquid. So automatically, gradually, heat transfer rate, heat flux will be reduced. Okay. So here the process. So next phase here, you can see here, unstable film will form. So there is a gap between due to this gap, heat transfer rate will be just heat transfer takes place between the solid to liquid, but due to these pockets, heat transfer rate will be decreased. So gradually from heat flux will be decreases, but this is the point where this vapor pockets and combines with each other and forms a thin film on this surface. Okay, this thin films that vapor resistance, the conductivity of the vapor layer is very less. So due to this one, heat transfer rate will be decreased. So this is the point where heat flux is gradually decreasing point. So leading frost point. So where heat flux very minimum, here heat flux Q is very maximum. Okay. So this is nothing but critical heat flux. So this is the Leiden frost point. Okay, you can see. So this is very important. Critical heat flux is very important. So next, that is the film boiling process. But from this point to the heat flux increases very rapidly because this layer, vapor layer, which is formed on the surface, acts as a solid, like solid surface. So then heat transfer takes place by radiation process. Radiation, due to the radiation, the heat transfer takes place from the solid surface to this vapor film. So from vapor film to just remaining liquid. So due to the radiation process, heat transfer rate will be increased. It increases rapidly. So this is the just like phases of boiling curve. We will see one by one. The first one is the interface evaporation, natural convection process. In interface evaporation process with no bubble formation. Okay. So with no bubble formation, less dense particles moves into upward direction. Those particles evaporated into air. Okay. It exists in a region 1, you know that one, that is nothing but a free convection zone. Here excess temperature is very less, that is delta T E is very equal to 5 degrees Celsius. Okay. So in this region, the liquid which is near the surface is superheated lightly. Okay, the liquid which is very near to the surface is superheated lightly. So the convection currents circulate the liquid and evaporation takes place at the top surface, okay, liquid surface. So due to this convection, less dense particles moves into upward direction. Those particles are converted into vapors. Evaporation takes place at the surface. Okay, the surface temperature must be somewhat above the saturation temperature. That is very condition. The surface temperature Ts should be greater than T saturation. Okay. Otherwise, only natural convection heat transfer takes place. If saturation less than T saturation, only convection process heat transfer takes place. But if the saturation temperature, surface temperature is greater than the saturation temperature, we will see the phase convection also. Okay. So, but without the bubble formation. Okay. So next one is the nucleate boiling. So nucleate boiling means, so here bubble formation we'll see. When first it has two phases, bubble formation and condensed again. Next to rapid bubble formation. Okay. So with the increase in excess temperature delta T, if you increase the delta T from 5 to 30 up to 30 or 50, okay, 30 degrees. So due to the increase in excess temperature, the formation of bubble formation on the surface at certain localized spots commences. Okay. So as indicated in the region 2, we know that region 2, the bubbles, these bubbles are condensed in the liquid without reaching the top surface, liquid surface, because the bubbles will be formed due to the excess temperature. These bubbles moves upward direction. When they are moving, these bubbles are condensed again because the water temperature which is away from the surface, this temperature is less than the saturation temperature. So due to the less temperature, these bubbles are condensed again. Okay. So this is the form. Bubbles condensed in the liquid without reaching the liquid surface. These bubbles will not reach to top surface. So that is the initial condition of nucleate boiling. Okay, with further increase in delta T excess temperature, the bubble formation are rapidly are formed rapidly and rise to the surfaces. Those bubbles formation increases rapidly. These bubbles comes into top surface. Automatically, these bubbles are uh, uh, so leaves the liquid and just mixed with the atmosphere. It means phase change occurs. Okay, so here this is nothing but with further increase in delta T, the bubbles are formed more rapidly and rise to the surface of the liquid, okay, resulting in the rapid evaporation. So this is nothing but reason 3. Okay, up to reason 3 you will see the gradual increase of heat flux. So at the end of the reason 3 you will see maximum peak level of heat flux. That point is nothing but a critical heat flux. Okay, the nucleate boiling is thus characterized by formation of the bubbles at the nucleation sites and resulting liquid agitation. So the bubble agitation induces considerable fluid mixing, and that promotes the sustainable increase in the heat flux. We know this. So fluid mixing and sustainable increase in the heat flux and the boiling heat transfer coefficient. So uh, heat transfer coefficient also increases. If H will be increases, automatically Q heat flux Q will be increases, because we know that HA into delta T. Okay, so this one is the next. Nucleate boiling exists up to 50 degrees Celsius. Okay. The maximum heat flux, so that highest point in the heat flux, that is nothing but a critical heat flux that occurs point here. So in that graph already noticed that one. So this is nearly 1 megawatts per meter square. You can see. Okay. Next one, phase changing, transition position from boiling, nucleate boiling to film boiling. The film boiling, so by increasing the excess temperature delta TE. Okay, so these bubbles, the rapid bubbles which are formed on the surfaces, these bubbles are mixed with each other and forms some vapor pockets on the surfaces like this one. Okay, so mixing of all these bubbles and forms pockets of the vapor pockets formed on the surfaces. Due to these pockets, conductivity of these vapor pockets are very less. So heat transfer takes place. Heat transfer rate will be decreased due to this less condensation. Okay, because the resistance of these pockets are very high. Okay, so automatically heat flux rate will be decreases in film boiling. Okay. So the trend of increasing heat flux, which increases in the excess temperature observed in the region 3, that is the nucleate boiling, end of the nucleate boiling. It is in reverse in film boiling. So fourth region. So that is called a film boiling region, because these bubbles are formed as a just like vapor pockets. The conductivity of the vapor pockets is less. So automatically the resistance of due to the resistance of these vapor pockets, heat transfer rate will be decreases. Heat flux will be decreases. So this is due to the fact that bubble formation is very rapid and the bubbles blanket. So the bubbles which are mixed with each other, the bubble blanket the heating surface. It covers the heating surface and prevent the incoming fresh liquid and taking their place. Okay, so that is the reason. Eventually, the bubbles coalesce and form a vapor film which covers the surface completely. So this is these bubbles coalesce are mixed with each other and forms a vapor film which is formed on the surface. So this vapor film, due to the less conductivity of the vapor film, so automatically heat transfer rate will be decreased. Okay, since the thermal conductivity of vapor film is less than that of the liquid, you know this one. Okay, so in film boiling, heat transfer rate will be decreased. So it reaches to a very less point, very low point. Okay, so within the temperature range, we will say 50 degrees to 150. So in between this type of region we can see. Okay, so conditions, film boiling oscillates between the nucleate and film boiling. The phase is referred as a transition boiling, because from boiling phase to film boiling position, we'll see here. So with further increase in delta T, vapor film, so it stabilizes, and heating surface is completely covered by this vapor blanket. Okay, so the heat flux is lowest at the at shown in the region. Okay, here you can see. So here heat flux is gradually decreases due to this vapor film, which is blankets the surface, which covers the surface due to this vapor film. You know that the conductivity of the vapor film is very less, so heat transfer takes place from solid to liquid. It opposes the heat transfer rate from solid to liquid. Okay, so due to this reason, heat flux gradually decreases. It reaches to minimum point. Okay, next, the surface temperature required to maintain a stable film, so are high. Under these conditions, a sizable amount of heat is lost by the surface due to radiation. Next, in this condition, we will see radiation comes into picture, because this solid surface act as a this vapor film act as a some solid surface. Then heat transfer takes place from the solid surface to vapor film by the help of radiation process. Okay, so due to this radiation process, radiation mode, heat transfer rate or heat flux again will be increased. It reaches to very high position. Okay, the phenomena of stable film boiling can be observed when the drop of water falls and a red hot stove. So you can, these are the examples. So the drops does not evaporate immediately, but dancing a few times on the stove. So this is due to formation of a stable film, steam film at the interface between the hot surface and the liquid droplets. So this is the one example of the formation of film boiling. So next one, we know that critical heat flux. So this is the, we can observe this critical heat flux point at the end of the nucleate boiling. So it reaches the highest heat flux, reaches to very maximum point, that is nothing but critical heat flux. Okay, critical heat flux or burnout point is the point of maximum heat flux on the boiling curve, at which transition from nucleate to, after this one we will see the transition from nucleate to film boiling. Okay, so this point is also called as boiling crisis, because the boiling process beyond that point is unstable unless of curve B is reached. Okay, the temperature at this point B is extremely high because of heat flux, normally above the melting of the solid. Okay, so if the heating of the metallic surface is not limited to a point A, so it is possible that the metal may get damaged. So we have to identify the critical heat flux. So because the protection of those metals. Okay, so thus we may be interested to operate the equipment close to this value, not beyond this one. So by identifying the critical heat flux, then you can maintain the this boiling processes. Okay, okay, these are the different textbooks for the reference. You can refer this one. You can understand the concepts of boiling thoroughly. Okay, thank you.
Like, share and subscribe. hit the bell icon for more updates.